let's start. We are starting a very important and very difficult chapter as well, and that's called functions. Today's date is the 27th of January 2025. Now, this is going to take us a while, not as long as is it not too early? Dekho, it's never too early to start yearly past papers. As soon as you're done with a considerable amount of syllabus, then you should start yearly past papers. That's what I always suggest. Even if, let's say, you're done with 40%, 50% of the syllabus, start yearly past papers, but only solve questions of the topics that we have covered. If that's what you're doing, then, it's never too early. So even if, let's say, you're done with like 20% of the syllabus and you do yearly past papers and you solve only questions that are from the topics that you've covered already, you can't say it's too early to start yearly past papers. Yearly past papers का objective क्या होता है? Yearly past papers के दो objectives होते हैं. एक objective होता है to prepare us for the actual exam. And, we get used to exam conditions and everything being tested at once. But when you solve yearly past papers before you complete the syllabus, the objective of doing that is so that you can revise all the concepts that you've learned, because it's difficult to sit down and memorize every single topic individually. So it's best that you solve a yearly past paper, which tests you in all the concepts at once, all the topics and all the concepts at once. Okay, yes, I'll share the marking scheme. I'll share a detailed marking scheme of the test also, inshallah. Anyway, so let's get to work. So we're going to do a bit of theory also of functions. Theory is something that not a lot of people take it seriously, but it's important. If you want to have a good understanding of functions, it's important that you do a bit of theory as well for your own understanding. It's not like you'll have fill in the blanks or short answer questions. It's for your own understanding. So first things first, what exactly is a function? Who can tell me what a function is? By definition, I'm not looking for examples. I'm just looking for definition, textbook definition. F of x, okay, f of x is a function. Not necessarily, I say f of x is there any, if it's f of x, it's always going to be a function. A number definition. What does that mean? That's not what it is. A number machine. Okay, let me guess. ये आप मेरी वो stream से देख के तो नहीं बोल रहे? Input and output, a mapping which connects a certain input to a certain output. Yeah, okay. So if I put what you guys have said together, then we can have the definition of a function. So basically a function is a relation. Okay, a relation. But one important point that you guys are missing is this, where every input has only one output. Okay, where every input has only one output. Now notice that there are three important terms over here. There's relation, there's input, and there's output. Let's go over these terms one by one. Now, what's a relation? Relation basically किसी भी equation को बोलते हैं. कोई भी equation where you have x and y, or not necessarily x and y. If you have like an equals to sign somewhere, that means it's a relation. So a relation is basically any equation that you can possibly think of. What's input? Input is something that you plug into the function. What do we call it? It has an official name, and that is the domain. Okay, and they are usually your x values. Then output also has a specific name in this chapter, and we call it what? The range. Good job. Okay, now range, या फिर हम इसको image भी बोलते हैं. Okay, now usually it's either y or f of x or g of x, depending on how you define a function. Could be f of x, could be g of x, could be h of x, could be, it's usually these three. Okay, now let's understand further the difference between a relation or a function. Okay, so there's a very important key point that you guys need to understand, and that is not every relation is a function. Not every relation is a function. So think of it this way. Can I say that every quadrilateral is a square? Can I say that? Does that make sense? No. Every quadrilateral is not a square. But if I say that every square is a quadrilateral, does that make sense? If I say every square, of course, every square has to be a quadrilateral, okay? So have you guys done sets in math? Like generally, you guys must have done sets in math. So think of this as the larger set, think of that as a set which contains all the relations. Okay. And then somewhere inside this set is a set which contains all the functions, just like the quadrilateral and square example. So you have a larger set which has all the quadrilaterals, a subset. Very good. And then inside that set, you have a set which is a set of squares. That means every square is a quadrilateral, but not every quadrilateral is a square. So here also, and not every relation is a function, but remember, every function is a relation. So you can write that down also. And I'll explain this. Okay, a lot of things will not make sense immediately, but they will gradually start making sense, just like how it was with trigonometry. So don't worry if you don't understand something immediately. But every function is a relation. क्योंकि देखो relation वो होता है कोई भी equation. Okay, any equation that I can form, you can form is a relation. But can we guarantee that equation is going to be a function, meaning that equation will have one output for every input? No, we can't guarantee that, can we? We have to test it out. There are some tests that we put a relation through before it qualifies for a function. Like for example, I can't guarantee and say every quadrilateral is a square because there are some properties of squares. All angles should be 90 degrees. That's not enough. All sides should also be equal. If these two boxes are checked, that means the quadrilateral in question is also a square. Okay. Now, a function can be of two types. Okay, a function can be of two types. कोई बता सकता है? The two types of functions that we have.
One to many and many to one.
One to many and many to one. No. Many to one, yes. But one to one function? Okay. A one to one function is basically a function where one input gives only one output. Okay, you plug in one value, you get something, you get one value in return. For example, yes, linear. A linear function is where if you plug in one value, you get one value in return. Any other function that you think if I plug in one value, I'll get one value in return?
Exponential.
Very good. Exponential. Exponential is also one of those functions where if you plug in one value, you get one value in return. Like for example, 2 power x. अगर मैं x की जगह 2 रखूंगा तो एक वैल्यू आएगी, 3 रखूंगा तो एक वैल्यू आएगी, 4 रखूंगा तो एक वैल्यू आएगी. Okay, but the idea is that we will get only one value in return. What's the other type? There's another type of function. Many to one. Good job. Many to one function. Many to one function, you can, the word itself, many to one, is self-explanatory. And that is where there are multiple, or as the word says, many inputs that give the same output. Okay, and same ka matlab one specific output. For example, quadratic and cubic. That's correct. Quadratic and cubic. Quadratic is an example. Cubic is an example. And there's one that we have just done recently. What's that? Where there are many inputs. Trig. Good job. Even trigonometric. Like for example, sine 0 is 0. Sine, no, not logarithmic functions. Logarithmic functions are 1 to 1. Sine 90, no, sine 180 is 0. Sine 360 is 0. So these are multiple outputs that give us the same input. Okay. What about one to many? One to many क्या होता है? Doesn't exist. That's correct. So a lot of people say that one to many function is not a function. Okay. That statement is incorrect. We don't, if it's not a function, we don't call it a function. We just say one to many is a relation, it's not a function. Okay, so let's write that down also. अक्सर लोग बोलते हैं कि जी वन टू वन फंक्शन होता है, मेनी टू वन फंक्शन होता है, वन टू मेनी फंक्शन होता है, लेकिन वन टू मेनी फंक्शन फंक्शन नहीं होता. Okay, that doesn't make sense. One to many is not a function. That's it. So one to many is a relation only. Okay, it's a relation only, and it can kind of exist like an inverse. Yeah. Not, sorry. Who can give me an example where you plug in one value and you get multiple y values? And we've done it. Let me tell you, we have done it.
Square root of variables.
Square root of variables. Acha, what happens before we take the square root? What do we have? Before we decide that, oh, we need to take the square root, no, not modulus. Square, that's correct. Can you think of an equation which has square on y?
Y square equals to x.
Circle, that's correct. Good job. Now, y square equals to x, that's correct. But something that we have also done, and that is basically a circle. So in a circle, if let's say you have x squared plus y squared, which is equal to 25, this, as we know, is the equation of a circle. Now, if I make y the subject, so y is going to be 25 minus x squared. And then once I make, once I make y the subject, because we have to take the square root on both sides. And when we take the square root, किसी का mic खुला है, जिसको छींक आई है उसका mic खुला है. खैर, so what was I saying? When you take the square root on both sides, you write plus minus, and that is why you get two inputs. You will take one input with, you get two outputs, sorry. You will get one output with the positive square root and one output with the negative square root. Okay, so that's what one to many basically means. This means that one output gives multiple inputs. No, sorry, one input. Ulta bol diya. One input gives multiple outputs. Now, earlier someone asked, how is cubic many to one? Because if you think of a cubic function in, if you look at a cubic graph, a ki value le lo 0. At how many different values of x can a cubic function be actually equal to 0? Think about it. Maximum 3. That's correct. So that means there are 3 values of x that technically give us the same y value. That means there are multiple inputs that give us the same output. Therefore, it's a many to one function. ठीक है, किसने पूछा था? Shumaya, is it clear now? Okay. Now let's do some examples. Let's visualize these functions, and let's do something called a mapping diagram. Okay. So here we have, let's say, f of x, which is equal to 3x plus 5. All right. And we're given that x belongs to the set of all real values. Okay. इसका मतलब क्या है? This means that I can, there is no restriction. Okay. There is no restriction. I can plug in whatever value of x I want, as long as it's a real value. And all the values that you and I are aware of are real values. Non-real values are basically not in our syllabus in AdMaths. They are when you take the square root of a negative value. For now, it's math error for us, but when you guys get to A2, that is when you will be actually dealing with square root of negative values. Right now, you don't have to worry about it. So this basically means that you're allowed to plug in all values, all real values of x. Okay, all real values of x. Okay, so plug in whatever you like, doesn't matter, you will always get an output. Now, let's say I plug in 1, 2, and 3. ठीक है, क्या plug in किया मैंने plug in किया 1, 2, and 3, and what will happen as a result? I will get 3 different outputs. Yes, I is basically short for iota, which is imaginary. So if I plug in 1, what happens? I get a certain output. If I plug in 2, what happens? I get a certain output. If I plug in 3, what happens? I get a certain output. Let's work out what the outputs are. So if I plug in 1, I get 8. If I plug in 2, I get 11. If I plug in 3, I get 14. Okay, so this is basically what a one-to-one function looks like. And let's quickly make a rough sketch of it. Not a rough sketch, actually. Let's use Desmos. So let's change this to, it doesn't matter actually. So f of x or y is equal to 3x plus 5. There we go. Let's change this to, there we go. This is the graph of a one-to-one function. And you can see that if I plug in 1, what do we get? I know it's kind of obvious, but let's look at it anyway. If you plug in 1, what do you get? You get 9, just like we saw earlier. Sorry, if you plug in 1, you get 8. If you plug in 2, what do we get? We get 11. And then if you plug in 3, what do we get? We get 14. Kind of obvious. Okay, now let's look at an exponential function. So let's take 2 power x. That is an exponential function. Can you think of a value that we shouldn't plug in an exponential function, meaning a value where the whole function might become undefined, or a value where you think we'll get an error? 0? Let's see. What is 2 power 0? 1? Okay, what is 2 power 1? Achha, if you guys are giving me the answer to 2 power 0, 1, that's correct. But if you're telling me 1 is a value that we cannot plug in, then that's not true. Think of any value of x that I shouldn't plug into this function.
Less than 0.
All right. Pick up your calculator, plug in -2 in place of x. Work out 2 power -2. What do you get? देखो 1 डिवाइड बाय 0 तो एक अलग बात है. 1 डिवाइड बाय 0 की बात नहीं हम कर रहे. Plug in -2 in place of x, क्या आ रहा है? Answer आ रहा है. A very large value? Yes, okay. If I plug in a very large value, chances are it will go to infinity, but it will still be defined, right? It will still be defined. We'll still get an output. Okay. So any specific value that we cannot plug in. What do you guys say? Is there a specific value? मैं कहूँ कि यार log, what do you mean by log? Pi. अच्छा, pi plug in कर लो, pi पे भी answer आ जाएगा. 2 raised to the power pi, you'll still get an answer. Pi ultimately is a decimal value, right? 3.1415, whatever it is. -999, what's the problem with that? -999 पे problem ये है कि हमारा calculator is incapable of giving us the output. It's not like there's a problem. The issue is that our calculator is incapable. If you, let's say, you use a very advanced calculator, you'll probably be able to work out what 2 power -999 is. Yeah, so we can plug in all values. Long story short, there is no value that you can say that we cannot plug in. We can plug in negative value, we can plug in 0, we can plug in positive value, decimal, fraction, rational, irrational, any value that you can think of. As long as it's real, you can plug it in. So the answer is x belongs to the set of all real values is going to be the domain. Okay, and this too means that we can plug in all real values. Okay, unless of course the question says that, you know what, these are values that you shouldn't plug in. ठीक है, वो restricted domain होता है. जब मैं आपको खुद ही restrict कर दूं कि भाई आपने बस ये values plug in करनी है, not because it's not defined, but because, you know, I just give you a condition for no reason. Okay, so here, if I plug in 3 different values, what will happen? I will get 3 different outputs. At no point will I get the same output for 2 different inputs. So here's 1, here's 2, here's 3, here's 2, here's 4, here's 8. So the output at 1 is 2, the output at 2 is 4, the output at 3 is 8. And we can check here that the output at 1 is in fact 2. The output at 2 is in fact 4. The output at 3 is in fact 8. Okay. So we can plug in all values. That is correct. All right. Now let's take a different type of function, and we have space here. No, we don't have space.
So what was the
Actually,
restriction? I didn't heard you.
restriction ये होती है, like for example, you will notice oftentimes with questions that instead of giving you this, the question might say, okay, something like this: x is greater than or equal to 2. That means we don't have this restriction because the function is not defined for any value that's less than 2. It's just that the question has given you a certain restriction that you can only plug in so and so values. That's what basically restricted domain is. And we're gonna look into it in detail. Don't worry about it. That was just to give you an idea.
So we can put any value in X if the question doesn't put a restriction.
If the question says x belongs to the set of all real values, like for example in this example and in the example above, then we can plug in any value that we can think of, any real value that we can possibly think of.
Sir,
Okay.
do real values include negative values?
Yeah, of course. All
Okay.
numbers that you see on a number line are real numbers.
Oh, is it?
Okay, then this begs the question, then if all numbers that are on the number line are real, then what exactly are numbers that are not real? Can you answer that question? If all numbers on the number line are real, then what are the numbers that are not real? No, surds and fraction को हम number line पे नहीं देख सकते क्या? 2/5, let's say 1 upon 2. 1 upon 2 is a fraction. Can I not locate a fraction on the number line? Of course I can. Separate number line? Yeah, but separate number lines. Square root of a negative number. That's correct. Square root of a negative number is basically an imaginary number. Okay. Now, here we have a quadratic function. Okay, what do we have? We have a quadratic function. Let's plug in 2. Let's see what happens. So 2 squared is 4. 6 times 2 is 12. 12 minus 4 is, oh wait, 4 minus 12 is minus 8. Minus 8 plus 8 is 0. So that means जब 2 plug in किया तो 0 आया. Okay, now stay with me. Let's plug in 3. Let's see what happens. If I plug in 3, so that's 3 squared minus 6 times 3 plus 8. So 3 squared is 9. 9 minus 18, which is minus 9. Minus 9 plus 8 is minus 1. So that means when we plug in 3, what do we get? We get minus 1. Okay. What happens if I plug in 4? 4 squared minus 6 into 4 plus 8. 16 minus 24, that's minus 8. Minus 8 plus 8 is 0. So that means what kind of function does this become? This becomes a many-to-one function. Why? As we can see that there are many values that are giving us the same y value. Okay, so we're trying to understand where these functions get their names from. So we can see why this is called a one-to-one function, because one input gives us one output. Somebody's mic, Ahmed, your mic is open. Unless you want to say something, then feel free to. Otherwise, you can mute yourself, please. And this is called a many-to-one function, and we can see why we call it a many-to-one function, because there are many. Many का मतलब ये जरूरी नहीं है कि बहुत सारी. Many basically means more than one. Okay, so if it's not singular, if it's plural, that means it's many. So this is an example of a many-to-one function. So you can see here that there are two different x values that give us the same y value, and that is the trend in this curve altogether. Like for example, if I plug in 1, what do we get? We get 3. If I plug in 5, what do we get? We also get 3. Okay, so that's the reason why this is called a many-to-one function. And the example that we did, we plugged in 2, got 0, we plugged in 4, and we also got 0. Okay, so this is an example of a many-to-one function. Now, while we're at it, let's also look at a relation. So the example that we used earlier, we're going to use the same one. That is the equation of a circle. So x squared plus y squared is equals to 25. This is basically a one-to-many relation, and it's not a function. So this is a one-to-many relation, and it's not a function. Now, who can describe to me the important points of this circle, as in what's the center, what's the radius? I want to see how much you guys remember while I'm drawing it on Desmos. Radius is 25. You sure about that? Radius is not 25, radius is 5. Okay, it's r squared. So it's x squared, x minus a whole squared plus y minus b, the whole thing squared, equals to r squared. So radius is 5, and the center is the origin, or basically 0. So this is what the equation, this is what the circle looks like. Okay. Now, why is this called a one-to-many relation? As we saw earlier, that if we plug in one value, we're going to get two different y values. Like, for example, if I plug in 3, and we can also see from the graph that we will get two different y values. Let's say मैं x को 3 रखता हूँ, ठीक है, और ये y है. So if x is 3, let's see what happens. So at 3, which is going to be somewhere over here, so what do we get? We get 4, and that's not it. We also get at -4. Sorry, we get 4. Yeah, and we get -4. That's going to be here. That's why it's... Sir, can you repeat? Acha, what's the definition of a function, Saad? How many Saads do we have? There is Saad Upal, there is Umayya Saadullah, and then there's me. Okay, that's cool. So can you explain to me what a function is by definition? Because see, that's the issue. आपकी जो definition है ना, बड़ी casual सी definition है. It's not a formal definition. It's where every relation has one output for every input. Okay. If you get your definition right, you'll understand why this is not a function. Okay. So here's what I'm going to do. I'm going to tell you the definition and tell me if we can apply that over here. If the definition of a function fits on a circle or not. The definition is that for every one input, we should get one output. So does that make sense here? Can I say for a circle that every input gives us one? Okay. Can I say that one input gives us one output? Can I say that? एक वैल्यू प्लग इन करने से एक आउटपुट आ रही है, ये नहीं कह सकते, ऑफ कोर्स नहीं कह सकते. So that means it is not a function. Yes, it gives two. All right, last, and that is a trigonometric function. Yeah.
So I noticed that this can also be a many-to-one function.
This can be a many-to-one function. How?
Sir, if you take x equals to 2 or x equals to -2, we get the same y value.
देखो, एक वक्त में ना एक चीज हो सकती है. पहली बात तो ये, if it's not a function, okay, if it doesn't fit into the category of a function, then it can't be a function. That's it. So what you're saying, हाँ ठीक है, वो बात सही है, लेकिन सिर्फ वो condition तो नहीं है ना for it to be a function. You're saying कि many to one इसलिए हो सकती है because there are many inputs that give us the same output. ठीक है, जैसे for example हम ये देखें, यहाँ पे एक input 3 पे 4 भी आ रहा है and similarly -3 पे भी 4 आ रहा है, ये कह रहे हो ना आप. लेकिन बात ये कि पहले तो हम चेक करेंगे ना कि क्या ये फंक्शन है या नहीं, उसके बाद ही हम चेक करेंगे what type of function is this. If it's not a function to begin with, then that's it, we're not even going to move forward. Sir, was a third example function as many inputs were giving one output. Dekho, that's fine. Many input can give one output. Dekho, once again, let's go back. Does that answer your question? Let me answer one question first. Emma, does that answer your question?
Yes, sir.
Okay. So your question is, that was the third example. Yeah, the third example is a function, but it's an example of a many-to-one function. ठीक है, मैं यहाँ पे function add कर देता हूँ, so you guys don't get confused. This is a function. It's an example of a many-to-one function. Why? Because there are many different x values that would give us the same y value. Now, you might wonder, you might think for a second, you might argue, well, it doesn't fit the definition of a function. Dekho, it does. Why? Because at a time when I plug in 2, I'm getting 1 output. When I plug in 3, I'm getting 1 unique output. When I'm getting 4, okay, only when I plug in 4, I get a unique output, meaning I don't get 2 outputs at a time. Yes, वो अलग बात है कि ये same output can also be obtained when I plug in 2, but the fact of the matter is that when you plug in one value, you get one value in return. If that's the case, then it's a function. If there are multiple values that you can plug in and you get the same value, that means it's a many to one. But if for every value of x that you plug in, you get a unique y value, that means it's a one-to-one function. Okay, make sense? Okay, now f of x equals to sine x. What kind of a function do you think this is going to be? You guys have already answered this question. This is going to be a 1-to-1, many-to-one. That's correct. So this is an example of, also an example of a many-to-one function. Okay, now don't worry about what we're going to do next. Tell me if the difference between a one-to-one function, a many-to-one function, and a one-to-many relation is clear. अभी सिर्फ इतना जवाब देना है. Okay, great. If it's not anyone who's still confused, please let me know now. Okay, brilliant. Now we're going to talk about some graphical tests. Okay, so sometimes you will come across a question where you will be asked to, you'll be given some graphs and you will be asked to identify which one is a one-to-one function, which one is a many-to-one function, which one is not a function to begin with. Okay, so there's an important note that I would like to add here, and that is it can only be applied, or used if graph is given. Okay. Now, what are the graphical tests? Yeah, thanks, Siko. Before I write them down. Horizontal and vertical. That's correct. There is the vertical line test. Okay. And there is the horizontal line test. अच्छा, अब पास और फेल की कंडीशन क्या है? पास और फेल की कंडीशन लिखने से पहले first let's write down what the vertical line test is for, what the horizontal line test is for. A vertical line test is to basically distinguish a function from a non-function. All right. So this is what a vertical line looks like, in case you've forgotten. Then a horizontal line test is to basically distinguish a one-to-one function from a many-to-one function. Okay, so that's what the horizontal line test is for. It's to distinguish a one-to-one function from a many-to-one function, and this is what a horizontal line looks like. Now, what are the conditions to pass and fail? As in, there's a test, but what can happen in a test? You can either pass or you can fail. So how do we know whether, I mean, how do we distinguish? Like vertical line humne bana di, but what now? What do we do now to figure out whether it's passed the test or it has failed the test? So the condition to pass is if it cuts only at one point. That's the condition to pass. Yes, we do have composite function in advanced also. And we have composite functions in O-level math as well. From now on, it was always a part of IGCSE Math, but now it's part of O-level math as well. And the condition to fail is that it cuts at more than 1 point. Okay, so that's the condition that so these are the conditions, or you can say the grounds on which we say it's passed or it has failed. Okay, now let's take a straight line. We know very well it's a function, but we're just trying to understand how to use the test. Okay, we know that it's a function and it's a one-to-one function. Is there any point on this graph where you might say that, if at this point I draw a horizontal, so what exactly has passed or failed? You'll understand in a minute. Just bear with me. So is there, in fact, let's start with a vertical line test. Yeah. Is there any point on this graph where you might say that if I draw a vertical line at so-and-so point, it will cut the graph at 2 points? Can you say that? Can you point out a specific area where if I draw a vertical line, you might say that, well, it's cutting it at 2 points. Can you say that? No. I can take this vertical line, I can drag it anywhere I want. It will always cut it once, which means that it has passed the vertical line test. And what happens if it passes the vertical line test? That means it is a function. Okay, so this is a function, and we saw that earlier also. We know that this is a function, but this is how you can graphically test whether it's a function or not. Okay, what's the rule? The rule is you draw a vertical line test anywhere you like, or you think, is there a point where if I draw a vertical line, the vertical line will cut the graph twice? Since there's no such point, that means it has passed the test, which means it is basically a function. Okay, what about a horizontal line? Is there any point on this graph where I draw a horizontal line and you might say that it will cut the graph twice? Is there any point on this graph? No, there isn't. And because there isn't, that means it has passed the test, which means it is not only a function, but it's also a one-to-one function. Okay, so let's go back. What's a vertical line test for? It is to distinguish a function from a non-function. So it passed the vertical line test. That means it's a function. What's the vertical line test for? A horizontal line test for? Horizontal line test is to distinguish a one-to-one function from a many-to-one function. So if it cuts it at more than 1 point, that means it has failed, which means it's not a one-to-one function. This means it's a many-to-one function, but this didn't fail. It will only cut it once no matter where I draw it. That means it's a one-to-one function. अभी इसकी टेंशन नहीं लो, अभी इसकी टेंशन नहीं लो कि एग्जाम में कैसे टेस्ट होगा. पहले आप समझ लें कि इसको अप्लाई कैसे करना है, तो फिर एग्जाम में कैसे टेस्ट होगा, you'll be able to figure it out yourself. Okay, although I'm not going to leave it on, I'm not going to leave you on your own. I will tell you, but don't worry about it right now. Okay, let's look at an exponential function. Is there a point where you might say that, if at that point I draw a vertical line, it will cut it twice? Is there a point anywhere on this graph where you might say कि अगर हम इसको इस point पे draw करें तो वो दो दफा cut करेगी? No, there isn't. Which means it passes the vertical line test, which means it is a function. Now, once we have figured it's a function, only then do we proceed to decide whether it's a one-to-one or a many-to-one function. So let's say I draw a horizontal line here, 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 at multiple points. Is there a point where you might say that, if I draw a horizontal line here, then it will cut it at 2 points? No, there isn't, which means it passes the horizontal line test, which means it's a one-to-one function. Okay. Now, here, let's start with a vertical line test. Is there a point where you might say that, if I draw a vertical line at so-and-so point, it will cut it twice? There isn't. Okay. So you can think of it this way, that take a vertical line and drag it throughout the graph, and you'll notice at no point will the vertical line cut this graph twice. It will always cut it once. But what about a horizontal line? Horizontal line cuts it twice, which means, what does that mean? What does that indicate? If a horizontal line cuts the curve or cuts the graph twice, ये किस बात की तरफ इशारा कर रहा है? What type of a function is this? अच्छा, इनवर्स के हम बाद में बात करेंगे, ठीक है? You're right, by the way, that's spot on. It doesn't have an inverse, that's correct. But we're going to talk about that later because we haven't done inverse yet, so we're not discussing that. But yeah, you're right. It doesn't have an inverse. Good job. That means it's not a one-to-one, but it's still a function, right? Because it's passed the vertical line test. That means it's a many-to-one function. Okay, it is a many-to-one function. Okay, now I'll leave this horizontal line over here and I'll write it down so that later on when you guys are revising, you know what it's there for. This is a many-to-one function. Okay, what about a circle? If I draw a vertical line, अब ये ना बोलना कि अगर मैं यहाँ vertical line बनाऊं tangent to the circle तो वो एक ही point पे cut करेगा. The idea is not a specific point, but at every point on the graph. Okay, you might argue that, well, if I make a vertical line which is just tangent to the circle, it will touch it at one point, therefore it is a function. No. The idea is that you take a vertical line and you're able to drag it anywhere and the vertical line only cuts it once. Here we can see the vertical line cuts it twice. Therefore, since the vertical line is cutting it twice, okay, I'll erase this. Therefore, this indicates that this is not a function. Okay, so the fact that the vertical line cuts it twice, this indicates that it's not a function. If it's not a function, should we even bother and check whether it is a one-to-one or a many-to-one function? Of course not. Okay, there's no point. It's like, let's say, to get into a certain college, you need to pass the exam and you need to pass the interview. But God forbid, let's say first is the interview and then is the exam, or first is the exam and then is the interview. What happens if you fail the exam? Then you're not getting an interview call anyway. You have to first pass the exam to get an interview call. So same concept applies, same logic applies here. It has to first pass the function test for us to decide whether it is a one-to-one function or a many-to-one function. Okay. Now, last, let's quickly wrap things up. This is a function because at no point there's no point where if I draw a vertical line, it will cut it once, it will cut it twice, it will always cut it once. That means it's a function. We saw that. Now let's see what type of a function is this. Well, if I draw a vertical line here, we can see that it's cutting it twice, which means it's a many-to-one function. Now here also you might argue that, well, if I draw a line which is just tangent to the curve, then it will cut it once. You're wrong. I mean, you're right in isolation, but you cannot just test this part and say that it's a one-to-one function. You have to make sure that the condition is true no matter where you draw it. So therefore, it's a many-to-one function. Okay. Now, any questions so far? Is the test, the way that we test it, clear to all of you? Okay, great. Now, the next concept is we're going to do domain and range in detail. We can't do it right now, obviously, but let's write it down and see what it is. So domain, as we know, are all the values of x that you can plug in. Okay, and range are all the output values. So just as an introduction, you might have seen something like this, where you have a rational function and then इसके साथ अक्सर कुछ ऐसी चीज लिखी होती है. ऐसा क्यों होता है? Who can tell me? Acha, also before I forget, you will find a worksheet after today's class. Don't do it. In fact, I'll just drag it down so that you know that it's supposed to be done after class 2. Because the worksheet contains domain and range questions. Because 5/0 doesn't exist. That's correct. Because if I want to keep this function alive, I have to make sure that alive ka matlab that there's got to be an output. The value of x that I plug in should be such that I get an output. But what happens if I plug in 3? Okay, what happens if I plug in 3? Let's see. I'm sure you guys already know, but just for the sake of doing it all the way through, let's actually do it. So if I do, suppose 5/3 minus 3, the denominator becomes 0 and we get a math error. मैथ एरर का मतलब कि 0 पे ये एक्चुअली डिफाइंड नहीं है. ठीक है, अच्छा इसको और जरा बेहतर तरीके से समझते हैं. ये नहीं कि सिर्फ मैथ एरर आ गया बस काफी है. being AdMath students, you guys, your understanding should be thorough. Is anything undefined imaginary? Yes. Yes. If it is not real, that means it's imaginary. That's what it means. If it's not real, that means it's imaginary. It's imaginary, yes. अब देखो, you can see that for every value of x, we're getting a certain output, but x0 यहाँ पे है, ठीक है? Now when x is 0, when x is 3, okay, which is by the way somewhere over here, I cannot see the corresponding value of 3. Okay, I can see the corresponding value of every other number. Like, for example, if you want to find out, well, what's the value of y when x is 10? Here it is. And I can see every corresponding value for every value of x except for 3. क्यों? क्योंकि the second you plug in 3, the function becomes infinity. अभी भी आप देख लें, if I take this, if I take a specific point, it's 3.06. It's getting closer and closer to 3, but it's never actually going to be equal to 3. Why? Because if the denominator, if you plug in 3 in place of 0, in place of x, the denominator becomes 0 and the function becomes undefined, which is why we say that iske domain mein 3 nahi hona chahiye. 3 should not be part of this domain. Why? Because 3 makes the function defined. So long story short, what's a domain? Domain are basically all the values that can be plugged into the function. So it will never intercept. No, it will. I mean, if let's say x is 2.999, you will still get a value, but you will never get a value at 3 exact. 2.99999 pe bhi value aa jayegi. But the second it's 3, it becomes undefined. Like, for example, imagine that you plug in 2.99999. You will still be able to solve it, right? Yes, you may not be able to pinpoint what the output is, but you will still be able to solve it. But how do you solve 5 upon 0? How do you solve 5 upon 0? You can't. Acha, dekho, I didn't say that it doesn't become 3. I said that you cannot plug in 3. Why? Because if you plug in 3, what happens? If you plug in 3, the whole thing becomes undefined. Okay, that's the issue. So the range is basically all the output values.